Welcome to the Pinpoint Asia podcast. Today I have Arun. Now, Arun is an expert on data science. He has worked in the healthcare industry, he's worked in insurance, and today our goal is to understand the applications of data in different domains.
Sure.
And this guy, as you gather from this conversation, has a lot of information on data. So what we need today is a dumbed down version of what you've done.
Sure.
Right? I'm going to start off by asking you to please introduce yourself and your background to our audience.
Sure. My name is Arunabha Gupta. I have been working since like 14 odd years, and I've had a lot of experience around working in the American market, European market, and now in Southeast Asia across things like banking domain, retail, insurance, pharmaceutical. They're the primarily four domains I've had worked upon. One interesting bit about my experience is also that it's been subjected to a lot of transition, because at the time when I started my career 14 odd years back, we were transitioning in terms of data warehousing, then the data sciences happened, machine learning, and now we are into AI, right? So I've been constantly subjected to a lot of transition, and I understand that over this experience, that what does a transition mean and which all use cases get a priority in such transition stage.
Okay, let me start off with one basic question, right? In your opinion, what is data science?
So, in my opinion, data science is kind of a subject where you kind of apply. So, it's not a new subject to start with. It's like something been there for a while. It's not reached the masses until a certain point in time. And now, because data was always there on the corner, right? So, data is a very big industry, been there. But the application was not something which had its value established. I guess data science allowed that, okay, fine, I can now predict who is that customer, whom I can retain, whom I want to retain, and whom I don't want to retain, or maybe which employee is about to leave. These are inherent problems. They were always there. Now, data-based decision making has only taken place and taken the forefront in the last 20-30 years, and that's where data science comes in, right? So, application of statistics and mathematics into real-time problem solving, which has been inherent in our natural self, but repurposing it.
So let me ask you this then, right? So we've heard about data modeling, and it's been around for. What's the difference between, say, data modeling and data science?
I would say they are interrelated. So if you say, so let's break it down like this. Artificial intelligence is like, what is artificial intelligence? Is part of us. Artificial is you're replicating it outside of a human. So artificial intelligence is often an umbrella term under which you have got data sciences. They've got data engineering. You have got something like, and then under data sciences you have things like data modeling, feature engineering. So they're all interrelated. But if you see, it's a big house, say artificial intelligence, in which there is one room which is data science, inside which there is one closet which is data modeling. So data modeling is an inherent part of how you model the data, and it's a step after you have prepared the data, right? So it's a mature step or a matured process stage of data sciences. Before reaching modeling, you need to first curate the data. And data modeling is also essential, where we are replicating the business processes, prioritizing that whether you want to deal with what kind of process has precedence over the other. So those business elements come into data modeling a lot. And the primary aspects of data modeling is more like application of different statistical formulas, different statistical instruments to kind of make the modeling more accurate.
So is it fair to say then that data science, you have artificial intelligence, then you have data science, and under data science you've got data modeling?
Correct.
Is that accurate?
Yeah. Correct.
And data modeling is like how you can come up with a pattern.
Yeah. So basically, I would say that for your insight to come, say for example, you have curated the data, right? The data is ready. You have the consumer also ready, who is willing to take insights. Now, for the insights to generated, it has to be generated in sync how the consumer has been consuming over the past. Say for example, a team within the company who has been doing say reserving has been looking at certain metrics. Maybe they are curated by another team, or it's a manual process or something like that, right? But there's a certain format, there's a certain way the data has been consumed. Now, before the data science or the data application of the model is done, you need to first understand how the consumption happens, right? That you need to curate the modeling, that is the relationship between individual entities, how the relationship, what's the primary keys, those things established primarily, and also the modeling. And when I say also takes into account that what is the accuracy level. So, for example, if I'm looking for pregnancy, right? So pregnancy is a very funny example. The model should not start telling that a male candidate goes in is also pregnant, right? So the model should understand what it's saying, that the cohort and contextual understanding. That's why data modeling is so important.
Understood. What is the difference between that and say a large language model then?
Okay, this is a very good question. So we'll take a step back here. Data modeling is something where we, for example, in the past, there's a significant part of machine learning data sciences modeling part, where we have got a say a random forest model or a logistic regression model. These are a model, when I say, is nothing but a statistical formula in which you fit different components of your business process and data, right? That's a statistical formula. So that's one piece. Similarly, in the recent past, we have had the development of deep net, that is a neural network, deep learning networks, right? So neural networks development led to things around that it gives you a better stage of completion, more accurate, more absolute result. But the difference between a logistic regression and random forest versus a neural network's output is it's less transparent. Now,
Sorry, I got to back up a little bit, right?
yeah.
What was it you said? What forest was that?
Okay, so maybe let's take a step back. Maybe I'll break it into two processes. So you have got an objective to identify whether this customer will be retained or not.
Okay.
That's the objective.
Okay.
Now you can achieve this objective to standard machine learning process. Versus you can also deploy a new language model to do that, right? Now the only difference is business wants a transparency, that what is it, a black box model or is it a white box model? When I say white box or black box, what I'm trying to say, it's relative, that am I able to understand on what basis was this decision taken? That kind of erodes towards when you move towards a language model. Language model allows you to kind of answer the same business solution from a for a wider audience from a language standpoint. So basically, when I say it is a neural network in the back end, but it is being trained, say, from the internet corpus. So it is not always readily trained or worked, compiled in a manner to curate your specific business problem. So that's what I'm trying to achieve. So whereas the statistical machine learning model is curated just for your business problem. So if you ask OpenAI, ChatGPT, say for example, is this resume good or not? Now it will be judging that resume from all over whatever data it's been trained. Now on the contrary, if you train a machine learning model, the way you judge a resume, it will be judging based on your framework. Now there is the part where the innovation is happening as of today, that you take a large language model, fine tune it the way you want the decision to be taken. So there is a differentiating factor how Pinpoint chooses a candidate versus someone else, right? So that framework curation is more absolute in case when you are doing a machine learning model, because it's more under your control. On the language model, to kind of get it under control, there's something called fine tuning. You need to bring it in.
I see. So let's go with a practical example for just to understand this, right? Say, just build on your example. Say the general recruitment is that a candidate from any university will do, right? And who's got, say, GPA of 4, or 3 and above, right? Say for Pinpoint, we need candidates from specific universities, right? Who've got a GPA of 3.3 and above, for example, right? Now, in the context, from what I understand, right, in the context of machine learning, what we would do is to have plenty of resumes, and we would tell the model that you got to look at these universities only. And this, so long as the candidate comes from a particular university that I have chosen, and the GPA is above 3.3, then it's good. That's the model it understands, right? And then the general model is that someone says yes or no, and then looks at the broader concept, right? What I'm trying to understand is, over here, what is the neural network? What does that exactly mean? And also, how do you go about training something like that?
Okay, so first thing first, we'll answer this in stages because it's a very complex scenario. It's very difficult to explain, but it's important. So when you take the machine learning route, that is, you are training a model, you undergo a stage called data preparation, feature engineering, data engineering stage. So that's where you kind of curate the data. Now your expectation is that you wanted 3.3, you wanted from a certain set of universities. So the data will already been subjected to filtration and cleaning, subjected to your business rules. So the data before it goes to the model for training purposes is already as per your expectations. So the training is done as per your expectations. That's where machine learning models had its place all these years. Now neural networks can also be trained on the same data, right? There's nothing stopping you. Now on the contrary, you can deploy a neural network, no questions asked. But when you want to consume a ready-made model, like for a chat GPT, you're asking the chat GPT, right, okay, fine, these are my parameters, you write a prompt, and then you give a set of resumes, chat GPT is answering. Now you need to understand, you are asking a trained model. You're not training the model. You are asking, so that's the term called foundational model. So you're asking a trained, already trained model. Now what was it trained on? You don't have a control. Now it will answer you based on what has it been trained on. Correct? Makes sense, right? Now it might have a bias, it might not be right, it might give you some additional reasons, so you're not very confident about it. Now you can then take this model, that is the ready-made foundational ChatGPT model, say any of these models, right, GPT 3.5, 3.4, or maybe like 4.0, and fine tune it with your data, saying that if this resume is 3.7, comes from University of, say, Wharton, say accept. So that is called fine tuning, and that is where the application as of now is happening. That is, you have, so no industry will, so that's what I was talking, right? So no industry will go out of their way. Nobody has more time, right? You have less time, more work. And that's where the value add is. If you're able to do more work in less time, that's where the application of analytics, data science, LLM and all of that, right? That's where efficiency comes in picture. That's where transitions into profitability. Now, in this way, if I am trying to say that, okay, fine, my machine learning model in the past was able to do this much, but there was quality issues or there was something. And for that, it required certain amount of data. And now I say that I don't even need a machine learning. I have a model which, if I fine tune with this data, can do answer more. So then it kind of curates. So because a machine learning model, when it's deployed, needs enormous number of volume of data. A language model to fine tune needs even more volume of data. So prerequisite is how well you know about your process, how much data you have, and then how you can kind of curate the process.
Understood. Can you also explain what a neural network is?
Sure. So neural network is the brain, right? So it's very simple. So all our lifetime we have been exploring our body. So there must be some reason that the head sits above all of us, right? So that's where the decision making happens. So that neural network is a replication of the same. So neurons are something with which you kind of have impulses, stimuli. So when you feel that, when you are touching yourself, you are feeling, it is because it's controlled by some sort of a stimuli which goes and looks up a neuron. So the neural network is a replication of the set. So you have got a layer of network of different weights. So basically, I'll give you a simple example. Say let's take implication of how pictures are created in photography, or that's the computer vision neural network, right? So if I take your picture, the first layer of picture is generally black and white. So the first film on which color is added. So black and white, how it is colored is that you are on a white plane, and whenever your body parts are there, it's illustrated based on the intensity of color in terms of black pixels. So the network will learn positioning, that okay, fine, this position, this weight. So it will give you weightage and weights and understand, okay, this is the face. Next time when you come up in front of the camera, it replicates and understand if in this position, this is a face, yes. Is it having a record? Yes, let this person in. So neural network is a replication of how we function, how we see things, how our mind works. It's a very small part of it. But to be honest, it is a layer of layers, both hidden as well as processing layers, and that different terminologies I can dwell into, but I would not to keep it simple. But to be honest, it is nothing but a layer based decisions where each layer component adds a attribute of character to understand, make it understand whether this what about this person are you understanding. So for example, this is a human, that's one network. This is a man, another network. This is Vince, another network. So then stitch all the networks together is something called a neural network.
What's the difference between then, right? Training something without a neural network versus training with a neural network?
No, there is no tuning without a neural network. So to honestly, language model is nothing but a neural network. It's an implementation of a modified implementation of a recurrent neural network. There are different forms of neural networks. There is convolutional neural network, recurrent neural network. So recurrent neural networks found its place in translation, language, conversation. Because when I say Vince is here, there it can be that Vince is here. But if I put it together, Vince is here means something else. If I rearrange, here is Vince, it means something else. So the meaning has to be in sequence. So that's what there was a path breaking paper that attention is all you need, which came from Google's brain office. And that's where they figured out that implementation of RNN, that is a recursive neural network, with a transformer architecture can give way to better results. That gave way to the boom of language models, what we see. So on the contrary, means on the overall basis, a language model when you talk to is nothing but a neural network implementation in a different architecture called transformer architecture in the backend.
I see. So, one more basic question, right? So, I understand about neural networks and the different layers, right? So, does this mean before all those existed? Like, for example, say going back to the original example about the CVs, yeah? So, if the CV, for example, is from certain universities, then for that, you don't need a neural network, right? So, say I have some basic data and I want to build a data model, right, based on my basic data, right? I can do it without a neural network, right?
Okay, so this is a very, very important question. We need to dwell a bit again backwards. So historically, when we said data, let's look at Microsoft. Microsoft came up with their Office collection, and the first product, which not one of the first product, which was path breaking. If you see the old advertisements, Excel was like the word Excel, the how the it worked, because it was giving a shape to our data. So in one way, you can divide the data into two parts, structured and unstructured. So a lot of decision making was focused on structured data. What about the unstructured data? Now, by virtue of what do you mean by unstructured data is a PDF file on which a resume is. Yeah, so you came up with OCR, that is reading from PDF, but it was not very absolute. There are a lot of softwares, but it did not give, they were often missed because the PDF in itself has a layout, the Word document has a structure. So there was always an overlap. There's no absolute answer yet. So then came the world of NLP. So NLP came that I will able to draw extracts from unstructured data. That research and that development has led to language models today. So you have to understand that machine learning, data sciences, and it's my bad, I should have mentioned it before, is very good, absolute, that the prerequisite is the structured data. Now, for example, in your case, you might have 100 candidates in a month, out of which 10 are placed, but 90 candidates are also there. So you can also, but how do you draw results or draw insights from them? Either you sit down and write a data model and put a data engineering setup where each candidate's profile goes through and you have a data model populating and you have tables populating, then you build a model and stuff. Now you can do what is that you can deploy a machine language model, fine tune it with your set of PDFs and say these went in, these did not. For this client's profile is this. So for this client, these kind of resumes work, these don't. So that's a fine tuning capability. So dealing with unstructured data was the path breaking part of language models, neural networks, because there's a trade-off of clarity. So when I say transparency, now you want the solution or you want the transparency of the solution. So if you are going towards the unstructured data, often the transparency becomes a difficult, because it's very difficult to understand what caused the language model to take this decision. That you try to fine tune and make it better in terms of evaluation.
So it's almost like it has a brain of its own when it processes the data.
Yeah, obviously that's what we say artificial intelligence about, right? So you are kind of, when you are, so let's take a size idea of the size. So for example, when you train, say ChatGPT 3.5 was trained in data of around 2020, 2021, something like that, right? So the world has changed since then a lot. So the size of data, what is trained inside, and the time and compute and the resources is humongous. When I say humongous, it's like it's very big, and to achieve that, you need that kind of resources. Now, generally, data science projects are with a department, and a department are allocated to a particular organization. Now, the amount of money which goes in training a foundational model, like a ChatGPT 3.5, also the older ones, is so big that it's outside the realms of a department's financial capability. So that's where you see that you would not see a foundational model coming just like that, right? There's a lot of money which is which goes in. 6 million is not a less amount for setting up a model. There's curation, there's security, there's a constant maintenance. It's a massive affair. So where does the value lie is being able to consume them and transform these models into use cases which can help your business deliver more impact in the same amount of time. So the idea is not to reduce the time. You will have the same amount of time to deliver, but you need to deliver more in the same time. And that translates into profitability and efficiency. So efficiency goes to a CEO book, and profitability goes to the CEO book. So that's the impact.
One more thing I didn't understand is, they say that there's, for example, OpenAI, right? They spent $1 billion. But DeepSeek, they did the same thing in like 6 million, whatever.
Yeah.
These are all still big numbers, right?
Yeah.
Now, what I want to know is the money that they spend, right? My understanding is this, layman's understanding is that you have the unstructured data, right? And the computer is kind of like, you give it some parameters, and it's formulating its own so-called model, its own neural based on that data, right? That's where somehow you need those chips, the mathematical chips and the GPUs and all that, right? Is that where the money is spent? Like, where does the money actually go? Is it essentially the GPUs and the time that the computer takes to come up with its own model? But they also talk about paying human beings so that they can they can help the computer learn, right? So where does the money go, and how do you help the computer learn, and what is reinforced learning and all that?
It's a bit, I cannot comment absolutely on this, but I'll give you an idea about what happens and where the money goes precisely. I won't have an absolutely, Sam Altman is not my friend that I can answer that, but I'll give you an understanding what goes underneath. One thing, you're absolutely correct, that the compute capability is a very big thing. So contextual. So go back in 2010, 2011, 2012. The first laptop which my father bought me was 512 MB RAM. It was a compact laptop, and 512 was a big deal at those days. 128, 256, 5, and then Counter-Strike started happening in college, and the next laptop which came was 2 GB RAM, so it had a better graphics, right? On the contrary, the laptop which I have today is having 64 GB RAM. So I'm trying to give you a scale. So the scale of computation at mobility availability has significantly grown. The DDR5 RAM today, which is available in the market, is in itself 32 GB capability by smaller denominations. Now that is where the hardware has progressed. And because of the capability of the hardware to process more and availability, has the data science also grown, neural network grown, things grown. So that gives you one idea about where the money goes. The NVIDIA chipsets, which we are talking about, because of which NVIDIA has grown as a stock price and other related attributes about it, is the one retail one which we know. I don't know if there's something else as well, but that is also one place where those chipsets, those GPU drives are very expensive. If you go for GPU for training a model, you need GPU. It's buying a GPU powered machine is expensive. Renting it on cloud is expensive. That still is a small part. I guess a big part about it is failing fast and trying different things, because innovation is about evolving in different approaches. The transformer architecture paper, which a bunch of Google brain means employees came up with, was path breaking, but the path breaking required investment. So you have to have a forward-looking investment point of view. So when you quantify that OpenAI spent this much amount, this much, but you always have to say that, come up with this context that OpenAI had no support. It was completely going out there, bringing it in. Once it's established, there's something there based on which DeepSeek went out. So it's a constant competition. Someone else will come out tomorrow. So hardware is one piece. Second is the time. So embedded engineers, very important. Embedded engineers are engineers who train on chipsets, who train stuff. That is a very niche skill set. People who work on reinforced learning also is a very niche skill set. And getting that kind of skill set, people work for longer time also requires time, amount of money. And a lot is to do in terms of influencing the usage of these at that point in time. So imagine 2023 October, this ChatGPT boom happened, right? So prior to that, why didn't you not hear ChatGPT? Why didn't you not hear about language model as much? I know about language models from 2014-15, recommendation engines and stuff. But why does the media and masses don't know? Because it takes time. So there's an amount of money which goes in marketing and creating that awareness also. So there are different layers you need to understand. Today, DeepSeek AI is there in CNN, CNBC, Facebook, everybody. Child is talking on the bus, everybody. But why was this awareness not there in 14-15? For 14-15, if I would tell someone that, okay, fine, I'm working on a LSTM model, only a few set of people, my peers and colleagues, would be able to understand what's that. Nobody would understand what's BERT. So today things are changing. So that is where also the money goes in.
I see. Another question I have is, say, for example, there is a particular model like the OpenAI model, right? So is it possible that someone could essentially take the OpenAI model, right? And then from the OpenAI model, take all the data, fine-tune it, repackage it, and sell it as something else? Like, you alluded to fine-tuning before, right? So is it possible to steal a model that's been trained on the internet data and then repurpose it for your own?
Yeah.
Yeah.
That's what fine-tuning is about.
That's what fine-tuning is about, right? And you can resell it essentially, right? So you can essentially copy the data from OpenAI and come up with some application.
We need to be cautious about certain terms here. Copying data is a very different thing. It's a security scenario which you're talking about. Copying data is not what's happening. When you're using OpenAI's, say, one of the models, it's a foundational model. It's been made available to you. There's a license which you sign up. There are usage patterns which you sign up. There's GDPR compliance which you sign up. You don't have access to a data on which the model was trained. You have the absolute product. You have the phone, but you don't know how the phone was made. Correct? Now you cannot uncover how the phone was made with the phone, right? Similarly, with the model, it won't be able to tell you what data was it trained. But you can utilize it to repurpose it for your own use case.
I see.
Now, very important, like the point which you mentioned. Now, OpenAI charges a certain amount of money for accessing those models, right? It's already making money. So from that entity, for you to make money, it's not unlikely, because this entire conversation around language model, Gen AI, the end customer, being a company or an organization, is still worried, where is my data going? When I write this question, say for example, I'm writing, there's a compile time error in my code. It's a block of code, but it's a block of production code. Where is my block of code going? Because nobody wants to relax that side of it. So that's the reason you have a lot of special agreement. So the reason why Microsoft bought OpenAI, because now it's like, when I say bought, it's like more like, I would not say bought, but provisioning OpenAI inside Azure, right? So it's a special set up with organizations that, okay, when I query OpenAI, the data is under certain restrictions, it does not go out and blah, 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 blah. So data security is very important. It's at the most important aspect of deploying an artificial intelligence solutions. But when you are trying, that's the reason people are trying to fine tune it to bring it inside. Rather than buying a solution from the outside, it's more important to embed the solution inside. Inside, when I say organization. So there are channels like Olama and Llama which allow you to download the model also to your local system. Once you have it as a physical existence, then you can train it so that the data is not going anywhere else. That is also possible. But then it is okay for a PC, but if you do it for an organization, the vulnerability question is skyrocketing, because if someone has access to that server which has access, you're gone. So there are different angles to it. So data is not getting copied. It is how you repurpose. So the product marketing side of it is also completely changing. The marketing role, marketing landscape is going to change also. Subject, because you cannot just sell a data product, you cannot just sell a model. You're selling something on which you're going to build upon. So hence it suggests how things are happening. More and more organizations are going to be inward looking. What do I have? If I have in structured data, for example, I'll cite you an example from pharmaceutical. If I have a lot of trials, clinical trials done. So in the past, I've done a lot of trials, right? Out of which there's a small margin which have been successful. But there's still so much of trials data. I can repurpose to draw insights. There can be transactions, policies which are profitable, which are not for an insurance company. But not all policies, but I can draw insights. So it's more about where engineering and data sciences start help organizations look within and enhance their processes.
I see. I understand. Look, before we come into applications about in your field, I want to ask you one more thing, right? This fine-tuning bit, yeah? I mean, can anybody do it? Like, or do you have to have some sort of a special degree in something? Or for example, say going back to our example, so say I want to use the Chat GPT data, but I want to fine-tune based on our resume data, right? Is there a no-code, easy solution to it, or does someone have to hire some fancy guy with a PhD and all that?
See, I come from tech, right? So I've transitioned into business, and I am not a very good prescriber about no-code applications and platforms. I often feel no-code platform is more of a marketing gimmick, because you can do stuff, but if you don't know what you're doing, if it fails, how will you fix it? You still need an engineer to fix it, right? So no-code is a good place to be, but fine-tuning is still a very niche skill. I did fine-tune my own model yesterday night, so I know it's not easy. It's not a bunch of code. You don't know. It's like if some things go wrong, you need to know how to navigate. It's a very, very niche skill as of today, but with time it will only get better. It's a different ball game altogether as of now. So as of now, currently it's a niche skill, but it's a developing skill. Ability to fine-tune models is very, very rare today. So you can do it, we can do it, but it is not a very established, completed place to be. It's still worth exploring, still developing. Frameworks are coming up. You have got more and more platforms allowing you to embed this operations side of it, which is MLOps, where you can onboard models, use it, touch and flow, application embedment. So it's still a developing world.
I see. So when people now, these days you hear about, on the paper you say, I use AI for this, that, and all that, right? What they're saying essentially is that they're using ChatGPT or one of the other models. Is that what they're saying? Or?
Okay, this is funny. I told you, we started our conversation with a thought process that AI is an umbrella term, and I'll maintain that. If you go to the universities will maintain, professors will maintain. AI is an umbrella term. Now AI is trending. Share prices are going up. Board wants AI on the quarterly reports. What are you doing with AI? Now AI can be as simple as a data machine learning logistic regression model. AI can be any fields, right? AI is an umbrella term. When I say artificial intelligence, is anything but not a human person doing it, or maybe there's a recommendation which is coming in, right? So example, when you have floods and stuff, right, there are models in place been ages, catastrophic models which help you understand as a portfolio owner which portions of the portfolio are more sensitive, more risk prone and stuff. Either you want to depart from these part sections, move that kind of allocation to a more safe place, or maybe help empower those people saying that okay, if you take the right measures we'll incentivize you, or if you don't take the measures your premiums will soar and stuff, right? So there's always a prescriptive analytic side of things. There are three forms, right? Descriptive, predictive, prescriptive. So AI can be anything, not necessary. Now if you say that what in AI, so are you embedding a model, are you doing something, because models have been there for a while. When I say language model, that is where the buzz is around today. So when you say a company is citing that I am using artificial intelligence to reduce the cost for allocating resources to the right pool or right mapping to the right skill set or something like that, right? That is a big statement. And that's where the question is how, because everybody is trying to utilize artificial intelligence in different forms to solve, but everybody's trying as of now.
I see.
2023, 2025, we are still evolving.
I see. Descriptive,
Predictive.
predictive, and prescriptive, right?
Correct.
Could you describe that? Yeah.
Very simple. So, how many employees do I have today? How many and what are the subsections? So, how many employees are on EP? How many employees are Singaporean? How many employees are above a certain pay grade? Blah blah blah. Different questions you ask. Look at your own data and answer them. That's descriptive. By the word it is, right? Predictive is a forward-looking perspective. How many employees are more susceptible for leaving? How many employees are looking forward for a pay rise because they are done with their tenure and they're looking forward for a promotion? How many employees are expecting a baby and looking for maternity leave? That's predictive. Prescriptive is from an employee standpoint. If you take care of employees on the if you reduce the health is a employee health insurance budget, which has a variable and a fixed premium. So if you so you see most of your employees are under 35, fit, they like you don't want the special coverage of some sort of special cover. Reduce that amount and put that into the flexi, and that allows not just gym but mental wellness also. That can help you increase your employee retention, because now employees, if they are not very, there's a lot of work pressure and they are not getting enough time with family and stuff, it kind of bothers you, right? But again, the employees are not very comfortable opening up to within, because office space. Allow them access to something like better health. That comes with a license fee. Move that money from here. That's prescriptive.
So is it fair to say prescriptive is a subset of descriptive?
No. Prescriptive is the most premium. When I say most premium, because it's a forward-looking. So predictive is forward-looking. Descriptive is as of now. Prescriptive is beyond. Prescriptive is if you do this, that's what the consultants do. That's what the consulting firms do. If you take this route, they will not take the decision for you. They will just suggest you. If you take this route, it can be. At the end of the day, action is yours. So it is more guiding, and that's what leadership is all about. That's the reason prescriptive analytics is the most premium of form of offering, and that's the most niche place to be.
I see.
If you hire, says tomorrow, I don't know where I'm gonna go, but say tomorrow I'm working for a firm, and so I get hired into a place where that how do I navigate the AI strategy for this firm? So I'm talking. My words are very, 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 I have to be very cautious about how I'm going to comment, because I'm treading in a territory which is less number of people, not enough established, and based on which an organization is going to take a decision. So tomorrow if the decision goes positive, it's more credibility. But if it goes tanks down, it's less credibility.
I see.
Stakes are high.
All right, let's come back to your experience, right?
Sure.
Can you give us like a use case what you've done? So you've done healthcare and you've done now insurance, right? Yeah. Healthcare. What's been one of the use cases for you where you've actually used data to help solve a problem and with cost savings, etc., etc.?
Okay, interesting use case. say you have got, let's talk about normal Panadol. You have Panadol today, right? So in Singapore, that's CPC, that's you have got Panadol today, and you use it for your painkiller, correct? More generic drug. But paracetamol, that's the underlying composition, has been there for so many years. What's different about Panadol? As a customer, you would know you need a medicine either for a specialty or generic. So Panadol's consumption is generic. On the contrary, something like a specialty, like something like NSCLC, that is lung cancer, is specialty. So for undertaking development, that is pharmaceuticals, since COVID happened, COVID was a one situation where you had more patients than treatment available, hospitals available, infrastructure, doctor available. Correct. It was like boom of patients, right? That's what happened in COVID, right? Unprecedented. Now that allowed the companies to press on the always constantly evolving. What's my pipeline? What products I'm going to launch? Which areas am I researching? Why am I researching? Where are the patients based on which the trial is going to happen? How do I acquire those patients? What relationships have I established? So historically, all these industries, pharmaceutical, insurance, both of them have a very common thing. That is, end impact is a human life. And hence, they're very cautious about onboarding of technology. So historically in pharmaceutical lines, the relationship between acquiring patients, acquiring the specialized data and all of that, right, carrying out trials, was very human connect contact basis. Now, since it demands committing of resources and money in advance, there was a lot of uncertainty. When I say uncertainty, that you don't know whether the trial will succeed or not, whether you will get the right patient cohort or not, where you don't know whether this doctor is good enough for the diagnosis or not. You go a lot by word of mouth, right? So that's where data came in picture. We tried to bring in identifying the right patient cluster, right doctor cluster. That is the HCPs and the HCMs. That is the right healthcare professional and the healthcare facilities, healthcare organizations who are for a given disease, for a given indication, so that for the trials, we don't have to always always just go by word of mouth. We go by data. So for example, if I'm looking for psoriatic arthritis, it's a blend of two kind of diseases, right? So, and arthritis is very common amongst masses, right? But psoriasis has its own, it's a skin disease, right? So there is a blend. Now you want to understand, you want to undertake trials, but you also want to ensure that you contain the amount of money you spend on the trials and you maintain the profitability of the product. So that wise you try to figure out where is the right patient pool, which pool is making more, where is the right doctor. When I say doctor in terms of affiliations, what papers are they doing. You don't necessarily need to go to a fancy hospital and partner with them to get access to the right doctor. You need the doctor who can identify the diagnosis correct, right? So you might be sitting in some rural place. So when you put it on it's democratizing the process internally. That's one piece. That was instrumental. Second piece which really made a lot of difference was ability to generate cohorts very fast. So you might be knowing in pharmaceutical, there is this division called real world evidence, which is very, very powerful. What it does is two kinds of jobs. One, the research around, because in pharmaceutical there is a factory, there is a research, and then there is marketing and production and commercial side, right? So the factory is more implementation. Research is very key for a company, right? So that's where the science, biomedical research people go, right? Now they want to understand that, okay, fine, in the real world evidence, when I say real world evidence, hospital claims, x-rays, electronic medical records, electronic health records and all of that, analyzing the different data providers like IQVIA, then Optima, different Flatteron, different providers, right, for different niche. they go through these analysis and run that, okay, this data has this cohort, this setting is correct. So these analysis take time. So, but now if then there's a understanding of these data providers also, which is unique to a different analysis combination. So if you have a cohort engine, so we developed a cohort engine there for each of these data sets or data sources, which allow you to today generate insights by language typing different simple questions. So you write, I want this, like you mentioned, then the language model is fine-tuned to that data. It is able to connect to the sources, create a cohort, give you an insight. That's very fast. So you are able to draw more insights as an analyst for more trials in the same time. That's one piece. And the third piece was something very special. It's like on the lines of where my next product should be. To understand that what is the predominant disease which is affecting masses, where the money is, or what's the demography type which is getting impacted, because you need to also balance in the trials, right? What demography, you cannot have a precedence of one demography over others, you need to balance that. So those things also allow for product development, that is prioritizing on the commercial side which product takes precedence over more, because there's a combination, there's a specialty, there's a generic, all put together. It cannot only be specialty, right? So that's what exactly helped in the pharmaceutical world.
Wow. Okay. And what about in the insurance space? What did you do there?
In the insurance space, when I joined here in Swiss Re, it was more on the property and casualty side. And I still remember my interview process. I was told that generally to kind of, when an event happens, so giving a bit of premise, the property and casualty, unlike the life and health, is a short tail business. That is, year on year, you renew your car policy, car insurance policy, house insurance policy. But on the contrary, the life and health, you might be healthy for the first 45 years. You are okay, you are taking an insurance order, but your actual implications or realization start happening at a certain age, right? So there's a mortality rate, there's a certain amount of maturity rate, annuity and stuff. So PNC is critical that way, and application of analytics is also very difficult because data is difficult to get. So the problem which was thrown at me first was, there are primary perils, secondary perils. What is primary peril, secondary peril? Primary peril is like an earthquake. There's enough documentation, enough recording, enough material and government and blah 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 happening. But then something like flood has less documentation, difficult to gauge peril, something like a wildfire. So these two perils were thrown at me that, okay, I want to do an analytics. Now we kind of built different applications around that, partner with different people to kind of build property data, that, okay, these many buildings are there, but these buildings are susceptible to more flood, overlaying with event data, simulation, descriptive, prescriptive, predictive, everything. Did that for a lot of different markets, namely Australia, New Zealand, Malaysia, and also bits around that. Then extended it further on the motor side. On the motor side, there's things like pricing, the right customer acquisition cost. That is identifying the right cohort, addressing them with the right messages, implying behavioral economics in terms of messaging, identifying the profitable cohort, identifying the non-profitable cohort, and all of that, right? So there's a customer retention, customer acquisition cost, because in insurance today there are a lot of players. Over the recent last 2-3 years, insurance has seen a lot of growth. It's a hard market, very expensive insurance, and that has attracted a lot of companies to open up and extend businesses and provide insurance as a coverage. So there is a lot of competition. So you want to buy an insurance for your car, but you are paying $500 today, but your new insurance is charging $650. You want to maintain someone else will so losing customer is very easy, but retaining customer is difficult, and acquiring a customer even more difficult because of the marketing campaigns and all of that which you need to run. So we solve that problem of customer acquisition from your existing book, identifying the patterns, and the customers who have been identified are being addressed based on behavioral economics, SMSs and stuff like that. So that was pretty interesting stuff. On the motor side of other side, we also did risk scoring. That is say for example, I'm giving a real-time example that population shift has happened from urban. So let's take a Germany. Germany has east and west, right? So there is a lot of urban population in west and a lot of rural in east and something like that. So you over the time, because of the expensive nature of urban locations, be it Frankfurt, Berlin, there's a lot of population which has moved to the peripherals on the peripheral of the city or to the urban side of things. So urban movement has happened. How does that impact? It impacts because these road networks, road architecture, the by-lanes, highways are more curated towards urban. So there is less curation towards the places where the population is moving. That allows you to, if you have a habitat living across a highway and there's one exit from the highway, so a lot of accidents happen when these people have to travel back to home, work and home. Frequency is high and the road network is not designed that way. So if you have such accidents, you kind of identify, put them on layers. Is it that kind of analytics to identify where the accident's happening, what is causing, and kind of price the insurance accordingly.
I see. In all these cases, right? Did you use a large language model, or is that not the case for it?
I would say large language model has only come into precedence in last 1.5 years, right? So application wise, it's taking up right now. But like I said before, it is the deterministic problems, that is the problems which have been solved, which are being prioritized. Like for example, understanding what a person has written in a claim to kind of labeling them, which is a very important job. The work which I stated are very advanced in its nature. Language model can be applied to bits and pieces of it, but I would say these are in itself so niche because you're applying geospatial, looking at a road network, trying to identify. These are different perspectives to identify where the gap is. As of now, language model applications are taking up, and I guess the industry is still exploring. From an insurance industry, there's a lot of application of language modeling happening on the life and health sector where the data is available generally. So for example, you get these health records, which I was mentioning from a pharmaceutical standpoint. Those health records have details. Now imagine you go to one doctor. You then change your doctor because you moved from Bishan to now Novena. So you don't want to move places. That doctor had a different layout of prescription. This doctor has a different layout of prescription. You went to a different diagnosis center. They have a different blood test. So these are different layouts. To draw insights from different reports is a challenge. So being able to draw insights from different report, collating them so that it still accounts for the same patient from different doctors and different institutes and all of that, that incremental journey is where a lot of application of language models happening, because by virtue of its existence, life insurance is where you need a lot of proofs before you buy an insurance. On the contrary, when you have a car, you have got your registered car license, register a blue card or something like that, and that details is drawn. But unless you apply for that kind of telematics device on your car, company would not know where you are driving, right? But on the contrary, life and health is having that. So there is a lot of application of life and language modeling on the life and health side. On the PNC side also, there is a lot of language modeling happening, but primarily on the claims side. On the product design side, it's happening to kind of there's an underwriting book, rule book, which an insurance company has, because there are problems like say for example in Japan, you have got underwriters, senior underwriters who are aging, who are retiring, and then you have got qualified young underwriters. So there's an age gap, right? So they don't have the time to train these guys, and once they retire, they don't have the guidance from the senior. So kind of a language model to kind of ask questions to guide you and stuff. So there are different implications
I
that
see.
way.
Yeah. One last question about this before we wind up, right? The kind of model, the examples you were referring to, right, where geospatial analysis, etc. All that is essentially getting data, structuring them, applying a model, and then coming up with a solution. Is that accurate, or?
No, geospatial has is a niche practice. It's in itself a specialty line. and which is gaining a lot of traction. Geospatial is what you are looking. It's very funny. You have a customer, and you have the transactions. It can be in a Excel sheet. It can be in a report. But the moment you look at it on a map, it gives you a different perspective. So if you know that the customer's house is located in the fringe area near the forest, and there is a slope, you know the customer is more vulnerable to a wildfire. Rather than, so the geospatial gives you a different perspective altogether. It's a specialized branch which is seeing a lot of traction. A lot of language model embedding is happening there because it's such a niche skill. So language model is helping a lot of smoothing the process of onboarding the geospatial skill set. So for example, you can interact with the maps, you can draw insights readily. So that's a developing field right now. That is a combination of language model and geospatial. So geospatial is more about geospatial analytics, which is a specialized niche skill.
Well, Arun, that was a lot of information. I loved it, right?
Yeah.
Before we wind up, one more question.
Yeah.
Someone new coming into data science, say a young student, right?
Yeah.
I mean, obviously, you read about data, it's transforming the world essentially, right?
Yeah.
What kind of advice or what kind of suggestion might you have for a young computer science or a general student, right, coming into this new world of data?
Know the why. Y equals to mx plus c, everybody knows. But no, it's important to know the why. Why, when I say WHY, why are you choosing this model? Why are you taking this route? Why are you doing it is very important. And that's where the value is. Tomorrow, if your code is getting generated, but it will still be an answer to the question you ask. The ability to ask question, ability to navigate that series of questions rather than just consuming solutions. So for example, this is something which I often go back to. A decision tree was an evolution, but there were certain limitations because of which random forest came in picture. So if you just look at random forest as random forest, you will never understand why it exists. So instead of just looking at solutions, the perspective has to be looking at questions to which the solutions exist. And that is going to be curious. Being curious always helps.
Fantastic. And that's a good note to end this podcast on.
Sure.
Thank you so much. I loved it. I loved chatting. And for me, every time I speak with you, I learn a lot.
Thank you so much.
So thank you.
Thank you.